Hello, everyone. In this lecture, we're going to talk about statistical measures of data characteristics. So, for example, if you get a sample of n observations, or you can call it n data points. So you will have x1, x2. So those are all numbers to xn. Now, with this set of numbers, you want to find out some characteristics. Those characteristics include the location. So they are called numerical descriptive. You want to describe the characteristics of the data set, the data that you just got. The characteristics include where is the location? Location means where is the center? Or people call it central tendency. Okay? And location can be measured with mean, median, or mode. And the other thing is called dispersion. Okay? So dispersion means how much variation you have in this data set. So that is called range or variation. And also, if there is a shape, if you have a distribution, and what is the shape of the distribution? Then there are two characteristics you can measure called skewness or kurtosis. So skewness means that distribution, whether it's skewed to the right or skewed to the left. And the kurtosis means you have a very narrow variation or very wide. That means the person is thin or the distribution is fat distribution. So that's called kurtosis. Now let's have a look at each of these definitions. So what is a mean? So everybody have a pretty much know what the mean is. So the mean is a risk mean of a sample, okay, or the sample mean. It's called the X bar. You just sum all the observation together divided by n. So it's here. Those are all the numbers we got. And then we add them together and divide by 10 because we have 10 observations. So this is what we got, 141.2. So this is how we calculate the mean. So the median is defined to be the value which divides the data into two equal parts. That means the middle value. Half the values are above and half are below it. To obtain the median, order the data in ascending order. So first you need to sort the data from the smallest to the largest. As we can see, this is the smallest to the largest. You see the original sequence. This is the first data observation, but it's come here, and the fourth observation here. So you sort them first, and then you find the middle point. And for this one, you have even number. Then the middle point is right here. Okay, and then what you are going to do is you are going to take the 11 over 2, that's 5.5. So what you're going to do is average these two. Okay, so 5.5's observation is mean of fifth and sixth observation. So the median is 141.5. And if you have odd number, of course, you just find that number. You don't have to do this kind of approximation by adding these two middle value together and divide by 2. What is mode? Mode of a set of n measurements is the value that occurs with the greatest frequency or the most popular or common value. You see here, which one is more common? This one has 3, this one has 2, and this one has 2, and this one has 2, this one only have 1. So this is the most frequent value. Then this mode is 142. Measure of dispersion. First one is range. The simplest measure of the spread or variation of a set of data is the range, R, which is defined as the difference between the largest and the smallest value. Although the range is simple to use measure of variation, it only uses two extremes of the data set. That means the maximum and the minimum values. Therefore, it is significantly affected by the outliers within the data. So here, let's find the maximum. So this is our maximum. Where is the minimum? Minimum is 139. So 4 millimeter is our range. So you have variation. So this is called sample variance. So it is based on the idea of measuring how far on average each observation are away from the center of the data. For technical reasons, to average the square deviation, we divide by n-1 rather. And this is unbiased estimate because of degree of freedom. So I don't want to get into too much details in the biased or unbiased because the degree of freedom here, this is n, this is 1. So that's why we use n-1 instead of n. And this will give you, just remember, this will give you unbiased estimation of the variance. So the variance is measured, the sample variance. So here, note this is a sample variance. Okay, and sample variance we use S squared. And all the other summary statistics we have considered in the same unit is as a data. Okay, that's a better measure for practical use because this is a square, right? Not in the same unit, but if you take the square root and you got standard deviation, they will be in the same unit. Okay, so you have variance, sample variance, and sample standard deviation. Now let's have a look at the shape. Skewness, you see you have right skewed, so this is right skewed, then the skewness will be positive. And if you have left skewed, then skewness will be negative. If you measure the skewness equation is right here. If the distribution of the data is not symmetric, then it is called asymmetric and skewed. Skewness characterizes the degree of asymmetry of a distribution around its mean. And you have right skewed, positive, left skewed, and it's negative. We also have kurtosis. Kurtosis characterizes the relative pickedness or flatness of a distribution compared with the bell-shaped distribution or normal distribution. So here is the definition of how to calculate the kurtosis. You see, if kurtosis is like in the middle, not too fat, not too thin, and then kurtosis is 0. If you have a very small standard variation, then you will have a kurtosis greater than 0. Greater than 0 is much better, right? So quality is inversely proportional to the variation. That means if you have a smaller variation, and if you have a bigger kurtosis, you have a higher quality. And if you have a negative kurtosis, then this is pretty fat, then you have a bigger variation. So bigger variation means lower quality. Am I making sense? Now, random variable, a variable whose value are random, but whose statistics distribution is known, we call it random variable. So we have discrete random variable. So discrete random variable is that we can assume a countable number of values. For example, here we have 1, 2, 3, and this is 0.25, 0.25, and 0.5. So if you add them together, the total probability rule, you add all the possibilities together, you got 1. And the probabilities distribution, this is called probability mass distribution. This is also called PMF, probability mass function. And this is called PDF, probability density function. Okay, so it's right here. So PMF is a probability mass function. That refers to the discrete distribution. Okay, discrete random variable. And probability density function refers to the continuous random variable. Okay, and you have a normal distribution is a continuous random variable, and you have A and B, and you can find what is the probability you're going to fall into this range. Okay, so this is a PDF function. By the way, the total probability rule, that means if you integrate from the minus infinity to infinity, and the area under the curve is also 1. And if you add all these values together, it's also 1. This is called a total probability rule. And here is a normal distribution, normal probability function. The probability density function, we have 2, and one is mu, and the other one is, so this is a mu, this is a sigma. So sigma, and as we can see here, this mu is the mean and the sigma is the variance. But previously we used x bar and s square, right? Or s. And this is for the sample. This is called sample mean. So this is a sample. Sample mean, sample variance, sample standard deviation. But for population, if you have population, this is called mu and sigma square. and sigma. So this is a population mean, population variance, population standard deviation. So the difference is sample is a representative subset of the population, okay? And but a population means you have all units in the population and you just get all the data, okay? And this is estimation of population mean. This is estimation of the population variance, and this is estimation of the population standard deviation. And now you have mu and you have sigma, okay? Now a joke, okay? Why sigma doesn't like mu? It's because mu is mean, okay? Mu is too mean, so sigma doesn't like mu, okay? Just a random joke for normal probability distribution. Okay, so this is the end of the statistical measures.